Okay. The second problem, for the purpose of the recording, we can regard this as the first problem, is the following. Just give me some space, please. Sorry about this. I'm using two screens, so I'll just have to get used to this. Okay, so the second problem is again a problem on numbers. So let's just clear this, all these drawings, and okay, so here the problem says the following. The products of the ages of a group of children whose ages are all between 12 and 20, you have a rather huge number here. It's 10,584,000. The question is, how many children are there? Let's first understand the question. The question says you are multiplying the product of the ages of a group of children, right? A certain number of children, and their ages are all between 12 and 20. And the question is, you're multiplying their ages. You don't know how many children there are, but you're multiplying these numbers, and the answer is this horrendous number, which is 10 million something. And the question says, how many children are there in the group? Okay, so that's the question there. So let's just write down the numbers from which this product is taken. So it's 12 to 20, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Now we're not multiplying all the numbers. We're just multiplying some of these numbers. And some of them may be repeated, we don't know. All we know is that the numbers which are being multiplied are all coming from this lot. And this is the answer. So now, how would you solve this problem? How would you try to identify those problems? You've got such a huge number here. All right, what you have to see here is that just look at these numbers. And you see, if there's a product, we're not sure exactly which numbers are involved in this. But certainly there are many prime numbers which are involved, like 17 and 19. And all the prime factors of these. Like one of the factors of 14 is 7. So let's try 7 and see if 7 goes into this number here. So if you look at 10,500, this, you're not allowed to use calculators, but I'm going to write down the answers quickly because we're not going to waste too much of time. Now this 7 certainly goes into this. When you divide this number by 7, you're going to get this. All right. So we can see now that therefore 14, that's the only multiple of 7 in this lot. So 14 will be a factor of this. See? So this number is going to be, when you divide it by 14, 7 goes into 14 2 times, and 2 goes into the top 756000. Okay. Okay, so our number is, one of the factors is 14. So let's just record that. Maybe right down here at the bottom. So the number is 14 times something. And that something is this one here. If you look at this, you see 756. 7 goes into this as well. So we have another 14 in the slot. See, we are dividing by a number in this set. So the only multiple of 7 there is 14. So you divide this by 14. So there's another 14 in that lot. And now to do this, you don't need a calculator. You simply cancel the 2's first. 2 goes into 14 7 times. 37800. And 7 goes into that. You can just do it direct. It's 54,000 actually. Yeah. All right, so it's 14 times 14 times 54,000. All right, now you can see the remaining factors are coming from here. And 54,000 is 2 times 27. So the only prime factors of this, and of course it's 10. So the only prime factors of this are 2, 3, and 5. See, this is 2 times 27. So 19 cannot go into that, 17 cannot go into that. So these numbers can be eliminated, and also 13. And we can see 14 doesn't go into that as well. So the numbers that we are left with are these numbers. And we have to ask ourselves, which of these numbers multiply together to give you 54,000? All right? And to do that, now you have to think, well, I got 54,000. That means we've got 3 5s in that product. To get 1,000, you have 10 times 10 times 10, which means you've got 5 times 5 times 5. 3 5s, you need at least 3 5s to come to this. We need exactly 3 5s actually. How are you going to get 3 5s? Well, you can get 3 5s only from 15 and 20. Okay? But these only give you 2 5s. Because this is 5 times 3 and this is 5 times 4. So it means that one of these numbers is repeated. Okay, so we'll have to see that. So we don't know which one it is. Let's try 15. We don't know whether it is 15. And divide this 54,000 by 15 times 15 and see what happens. Well, 5 times 5 is 25. There's a 9 here. 25 goes into this 2160 times. And 9 goes into this 240 times. So you see 15 times 15 goes into this exactly. I'm not going into the details. And the other factor will have to come from 20, right? Or if you like, it could come from 15 times 12. So it's 15 times 16 is 240. So that is a candidate. And also 20 times 12 also gives you 240. And all those numbers are in this. So the question is not what the numbers are. The question is how many children. So these will give you 2, the last one, and you get another 4. So the answer is 6 children altogether. Okay, you can see this is a good example of what we call a non-routine problem. You have to use your logic and think about this problem and say, how do you find these numbers? And you have to have a fairly good a hold on multiplication and factorization to get to that. All right, so that is the third problem. Let's go into new share. Here's another rather complex looking thing. The next problem. All right, so the question here is, looks like a frightening problem. The question is, how many zeros will be there in the answer if this number here is divided by 11? Rather frightening. Okay, so this is the number. Now you're dividing this by 111. It looks like a horrible number, but you can actually divide it by 111. If you perform the usual...
Sir,
yes?
Isn't there too many zeros at the end? Shouldn't it be 4 zeros after?
4 zeros, yeah, okay, thank you for that. Yeah, okay, thanks very much. Okay, so when you divide this by 11, now let's just count the zeros that will appear here. If you want, you can divide it directly. Like for instance, 111 goes into this one time, but that might be a little bit frightening. Then you got 111 goes to 0 times, into 02, 0 times, into 022, 0 times, but into 222, it goes into 2 times. Right? Now we are here at this stage. And then you can do the same thing and go on. Like this. It'll be a long winded process. But if you use your common sense, you will see that those 4 zeros will still be there. This 0 will be there. I'm sorry. Let's just take that out. There will be 4 plus those 4. That 0, there are 2 of them here. That makes 3 and another 3. So that gives you 6. And then how many zeros? There will be no zeros at this point, but there will be 2 zeros for these 3 2s and another 2 zeros for these 3 2s. So the 2s will contribute 4 zeros. The 3s will contribute the 2 here, another 2 here, another 2 here. So the 3s will contribute 6 zeros. So you're going to have 001, you see, 003, 003, 003 when you're dividing. So we are only looking at the zeros. I've already counted those zeros. And these will give you those 2. There will be 2 there. There'll be another 2 here, another 2 here, another 2 here. So there are 8 contributions from the 4s, and that gives you 28 zeros altogether. Okay, I know that some of you would be quite lost in this because you might not be familiar with division, but when you are dividing, what I'm doing is I'm dividing normally. If I'm dividing 1, 6, 3, 8 by 2, what do I do? I've got 2 goes into 0, 1, 0 times, 2 goes into 16, 8 times, and so on. I'm doing exactly that. The only difference is that I'm dividing by 1, 1, 1, and that's not so difficult to divide by because these are all multiples, a lot of multiples of 1, 1, 1. Okay, so the answer to this problem is 28. Okay, so now let's get on to the next problem. So today you didn't have an opportunity to actually look at these problems. I put it on the post last night, and I'm not sure how many of you actually were able to access it or even see it. But from next week, we will have the problems well in advance. So you will have enough time to try the problems out before you attend the class, so that when we do these problems, you will already be familiar with what the questions are. Unfortunately, today we are not in that privileged position, and we need to apologize for that. But certainly from next week, it will be much better. And also, the numbers of the problems are there. There are some numbers which are called key numbers, will be on that problem set. Those key numbers are the numbers. These problems have been taken out from the book, which you have been told about, 1000 Olympiad mathematics problems. And you can go to the book and identify the problems as well. So when we get to that book stage, I will say a little bit more. But you will be getting the book by South African Maths Foundation is happy to tell you that you will all get this book free, and it sells for 520 rand. So you are very privileged to get a free book. It will be posted to you. There will be a USB which will be posted to you. It's going to be couriered on Monday or Tuesday, and hopefully you will get it by Thursday or Friday. And then you can open it up, look at the book, try to study it and see what's going on there before you come to next week's meeting, that is next week Saturday. So hopefully many of you, some of you have already got the books, but many of you, then next week, hopefully almost all of you will have the book. Okay, with those remarks, let's just get on with the matter at hand. So I'm going to clean this board and paste the next problem. Okay, so the next problem is, this is actually 10 to the power of 101. The program does not allow that. So this is 10 to the power of 101. If this number is written out in full, so you have the number we are looking at is 10 to the power of 101 minus 1. Now, this is a huge number because this number itself has got 101 zeros in it. Now you subtract 1 from that and you write the whole thing out, and the question is, find the sum of the digits of the new number. Right? Find the sum of the digits of the new number. Okay, well, unfortunately the class is so big that I can't ask you. If you want, you can put your responses on the chat column, and then we can look at it later to suggest how you think you can do this. Let me just give you a minute or so to think about it. Can you put that speaker off, please, whoever is? Galaxy, can you please put your speaker off? Galaxy? All right, this is unfortunate that somebody is speaking and they are not obeying the rules and disturbing everybody else. I think I might have to take that person out of earshot. Okay, this number had 101 zeros in it. And when you take 1 away, suppose you had 2 zeros and you take 1 away, your answer will have only 9s in it. It's 99. And there will be 2 9s. So if you got 2 zeros, you will have a number with only 9s in it. And there will be the same number of 9s as the number of zeros in the first instance. So there will be 101 9s here. See? Because when you had 2 zeros, subtract 1, you have 2 9s. So if you got 101 zeros and subtract 1, you'll have 101 9s. And that's easy. 101 times 9 is 909. So here's a problem which looks very difficult, but with a little bit of common sense, you see that you can actually figure out the answer to the problem. Okay, so let's just get to the next problem. Hope I'm not going to have any difficulty with this. Sometimes my cursor just suddenly stops and I have difficulty in trying to. Once I get used to the routine. All right, so the next problem is a problem in algebra. Okay, it does not copy some mathematics text. So let's just read this problem. P, Q, R, and S are different prime numbers, less than 20. What is the greatest possible value of? Now let me tell you what that number is. You want to find the largest possible value of this number here. It's P minus Q. What happened here? Okay, it's P minus Q over 2R plus S. Okay, so you need to find the largest possible value of that number. Okay. Now these are prime numbers. So what are the possible values of P, Q, R, and S? They are prime numbers less than 20. So you are going to choose your numbers from 2, 3, 5, 7. These are the prime numbers less than 20. So these 4 numbers, and they are all different numbers. So you're going to choose 4 numbers from this lot, so that this fraction is going to be as large as possible. What is the largest possible value of this fraction? We don't know what the numerator is. We don't know what the denominator is. But how do you find the largest possible value? Now, a little bit of common sense, a little bit of thinking will tell you, well, you have to multiply it by a large number as possible and divide by a small number as possible. Because multiplication of this fraction means you've got a number at the top, right? Which is, and this number here is going to be divided into that. So you want that to be very large and you want this to be very small. So you want to make this as large as possible. So you want the difference between P and Q to be as large as possible. Now let's have a look at the difference between P and Q. What is the largest possible value you can have for that difference? It can be 19 minus 2, right? And then you want this to be as small as possible. And we've already used 19 and 2. So you want 2R plus S to be as small as possible. So you have to choose the R and S from here. And if you want it to be as small as possible, you might as well choose the R to be 3. So 2 times 3 is 6. 6 plus 5 is 11. So here you get 17 over 11. All right, so this looks as if it's the largest possible value of this fraction. But just be a little bit careful here. Because we looked for the largest numerator, but why not look for the smallest denominator first? Right? So we look for the smallest denominator. The smallest denominator will, in that case, we can use 2 and 3, right? I'm doing it all over again. This is one answer I got. Oops, sorry. The one answer I got when I looked for the largest numerator. But now if I reverse the process and look at the smallest denominator, so the denominator is 2 and 3. So 2R plus S, you have to choose R to be 2. So that gives you 7. 2R. 2 times 2 is 4 plus 3 is 7. And then now the largest difference will be, you're not allowed to use this. The largest difference will be 19 minus 5. It's 14 over 7. And that's 2. Now if you compare this scenario, this is 1 and 6 11th, and this is 2. So this is the answer. That is the largest possible. That is not the answer. Because if you made the denominator as small as possible, you get a larger answer. So that is how you do this problem. You see, So far, it's all kind of common sense. It's not you're not using any high-powered mathematics or factorization or anything like that. You're just using logic and understanding what the question is, and go ahead and try to solve the problem. Okay, so the next problem that we have here is find the units digit of this number here. Now, I presume you all know what factorials are by now. You have seen it before because many of you have had experiences of this. But we can write it down. This is 1. 2 factorial is 1 times 2. 3 factorial is 1 times 2 times 3. Easier to say 3 times that because this is 1 times 2. So it's 6. This is 1 times 2 times 3 times 4, which is 24. It's easier to say it's 4 multiplied by 3 factorial, and so on. Right. Now you're looking for the units digits of this. The problem is that you got so many, you got 2019 numbers. God forbid, how are you going to work out this problem? You're going to add 2019 numbers. And how are we expected to do that without a calculator, A and B? We probably wouldn't live that long to add up all these numbers. Anyway, let's investigate a little bit further. These 3 dots are hiding a couple of things, because the next one will be 5 times this, which is 120. The next one will be 6 times this. Now you see something is happening. The next one will be 7 times this. And now you'll notice that all the units digits from this point onwards are all zeros. Now that's easy. You can add as many number of zeros as possible. The answer is still 0. So the units digits of this is just this number here. 3 plus 6 is 9. 33 plus some number with zeros at the end. And so the units digit is 3. 3 plus 0 plus 0 and so on. So that's the answer to that question. Again, it looks as if it's almost impossible to do, but with a little bit of thought, you see, hey, this is not so difficult. It's a trap here. Most of the numbers end in 0, so it's not so difficult to do. Okay. So let's get on to the next problem. Mr. Landa Ruba, can you please switch your microphone off?
Okay.
Okay. This question says, how many zeros are
So the trailing twos have to be squares instead of twos.
Oh, these are squared, huh?
Yes, sir.
Oh, okay. Oh, thanks. I've got some good readers here. So this last one is going to be squared. Okay.
So it's 52675 to the power of 2 minus 4735 to the power of 2.
All right. I got that. I'm just trying to, sorry. I'm trying to figure out, okay, trying to get rid of this thing here.
So just click away and double click on the text that already exists and try and see if that works.
Oh, okay, thanks. Oh, okay. Look, I'm just going to just take this thing away, very far away. All right. So what we have here is, you say this is 52675 squared. So let me make this a power here. This is 52675 squared minus 47325 squared. So the question is, how many zeros are there in the result of this, at the end of it? I presume it should be at the end of it. And how do you go around doing this? Well, for a start, one important fact in school mathematics is that a squared minus b squared is a minus b into a plus b. It's a very important factorization, a difference of two squares. So this is a difference of two squares. You got a minus sign. So you got 52675 minus 47325. That's your a squared minus b squared. So I'm subtracting these two numbers, and that's the difference between the two numbers multiplied by the sum of the two numbers. And the two numbers, when you add them up, you get 52675 plus 47325. Okay, now here you can actually try to work this thing out. And I'm going to just worry about the last few digits, because you got, if I subtract now, 5 minus 5, 7 minus 2 is 5, 6 minus 3 is 3, and then you have some other stuff there. Right? We're not worried about the other stuff because we are only interested in the zeros at the end. And here, when you add these up, you get 5 plus 5 is 10, those two 5s. 1 plus 2 is 3, plus 7 is 10, carry 1. 1 and 3, 4, and 6 is 10, you carry 1. 1 and 7, 8, and 2 is 10, you carry 1. 1 and 4, 5, and 5. Oh my goodness, this is got a lot of zeros in it. It's 100,000 actually. So you can see that this number is being multiplied by this. So this 0 here, if I absorb it into the next one, you're going to have a number with 6 zeros. There are 5 zeros there. And this doesn't have any zeros in it. So the answer is 6. This number has got 6 zeros at the end of it. Actually, they ask how many zeros are there altogether. So perhaps we should actually, there may be some other zeros here, but I see quickly that there are no other zeros. You get 15350 times this, and that number is 1535 with 6 zeros behind it. So altogether, there are 6 zeros, even in the other ones which we haven't seen. Okay, but you can see it because you are multiplying by 100,000. That's very easy to multiply. So all you have to do is to just subtract these two numbers to get the grand total. All right, so that's the 7th problem that we have done for today. And we're going to go on. Go on to the next question. Let me first clear this, all the drawings from here to make this thing Right, so the next question is this. Let's have a look at this. An integer k, when divided by 6, 5, 4, 3, and 2, leaves remainders of 5, 4, 3, 2, and 1, respectively. Find the smallest such k. Okay, so here we don't know what the number is, but we do know that when you divide it by 6, you're going to get a remainder of 5. Okay, so let's first try to do it like that and say, if we have which numbers have that property. When you divide it by 6, the remainder is 5. You can say, well, 5 itself, when you divide it by 6, the remainder is 5. The next one is 11. When you divide 11 by 6, the remainder is 5. So if you want the remainder to be 5, you just keep adding 6 to this. So when you divide this by 6, the remainder is 5. So you keep adding 6. And so on. So the number we are looking for is inside here somewhere. Let's put a few more so that keep adding 6. So all these numbers have got the property that when you divide by 6, the remainder is 5. You see? So the moment you start with 5, you just have to keep adding 6. Look, if you divide this by 6, you get 18, remainder 5. This 24, remainder 5. This is 30, remainder 5. So the trick is you keep increasing it by 6 and you're going to get the same remainder. Okay, now this says that when you divide by 5, the remainder is 4. All right, now when you divide by 5, you want the remainder to be 4. So here the remainder is 0, the remainder is 1, the remainder is 2, the remainder is 3. And here you got the remainder 4. Okay, so that is a possibility. And in fact, none of these have got remainder 4, and you have to keep going. But there are probably many others. For instance, all the numbers which end in 9 will have a remainder of 4. And also those which end in 4 will have a remainder of 4 when you're dividing by 5. See? You're dividing by 5, multiples of 5 either end in 0 or 5. So for the remainder to be 4, they must end in either 4 or 9. So that's how this 9 pictures up. Okay, now when you divide by 4, the remainder is 3. And this one, when you divide by 4, the remainder is actually 1. 29 divided by 4 is 28 plus 1. So this is out. So the answer is none of these here. This is further down the line. Okay, now the problem is we don't know where we are going to hit gold. Right? It could be at 597 or something like that, and we can't go on. So let's look for another way of doing this. Now, I want you to notice the following. Now listen carefully. When you divide by, notice that the remainders are 5, 4, 3, 2, 1. There's a pattern here. When you're dividing by 6, 5, 4, 3, 2. So this thing here is not a random set of numbers here. They have a particular form. So maybe the clue is here somewhere. And the clue is here, provided you use it nicely. Look, if the remainder is 5 when you're dividing by 6, it means that when you add 1 to this, it will be a multiple of 6. See, when you add 1, you're going to get a multiple of 6. Add 1, you're going to get a multiple of 6, 12, 18. So the number that we are looking for is k. When you add 1, it's going to be a multiple of 6. Right. Now, if you look at 5 and 4, you got exactly the same situation. Right? Because when you add 1, the remainder is 4. So when you add 1 to this, again, it will be a multiple of 5. So when you add 1 to k, it's going to now be a multiple of 5. Okay? So k plus 1 is a multiple of 6 on the one hand. It's also a multiple of 5 because it gives you a remainder of 4. And the same thing happens with 3. Right? When you divide by 4, when you add 1 to it, that number will now be a multiple of 4. So this number is a multiple of 6, 5, 4, 3, and 2. It's a multiple of all these. Now that problem is easy to solve. You're looking for the smallest possible k, which will make k plus 1 to be a multiple of all these. So you're really looking for the smallest common multiple of this. The lowest common multiple, right? And that is what you mean by the LCM. So you're looking for the LCM of these numbers, and you can use your school mathematics to see that the LCM is 60. So the smallest value of k, which will make all these things true, is 60, but the number you're looking for, k plus 1 is 60, right? So the number we're looking for is 59. So that is why we missed it. If you went a little bit more, 47, 53, 2 more, we would have come to the smallest k. Right? But we didn't know that at that time. So we used logic to get to the answer, 59. So this is a good application of LCM. And that is how you do that problem. It looks quite... You can do it by hand. You could have done it by going 2 more steps and you would have come to 59. But that's a rather uninteresting way of doing it. You'll have to admit the way I did it is a very interesting way because you can do it for a large number of problems. Okay, so the next one, let's get on to the next problem. Let's just clear my whiteboard. All right, I managed to succeed in that. Sorry about this. Okay, the next thing is we want to go on to the next problem, which is solve for x and y in terms of x and y. I deliberately did not put that down because this would not accept these mathematical terms, but the expression is x over 1 plus x equals y over 1 plus 2y. Okay, solve for x in terms of y. Well, this is plain algebra. Look, there's nothing very fancy about this. Cross multiply, you get y plus xy. You're solving for x in terms of y, so you'll bring all the x's to one side, wherever you see x's. And the x is okay here, and the y remains on the other side. So let's simplify this. X plus 2xy minus xy is xy, and you can take x out. It's a common factor, and there you have it. You got x in terms of y. It's a normal way of solving for x in any equation. You bring all the x's to one side. That is the main trick here, right? And then the x comes out, so you can isolate it from y. So that's the answer to that problem. It doesn't have much to do with problem solving, as you will see. It's just a test of school mathematics. The next one is again a little bit of algebra. And let's have a look at this problem. Here, again, I took the mathematics out, so I can write this thing down. So it says if, at the beginning of the sentence, they got if, that an algebraic expression, if A equals B plus square root of C over D. If A equals B plus square root of C over D, determine D in terms of A, B, and C. So you want to make B the subject of the formula. That is how it is explained in school mathematics in grade 10. You want to make D, there's a formula and you want to make D the subject. So the idea is to get all the D's on one side first, and D is only here. So you have square root of C over D equals A minus B. All right, so I got the D's to one side. There are no D's on the other side. You have to be careful with this. Okay, to get rid of the square root, you square on both sides. That's the way to get rid of square roots. You don't have to simplify it. Just square it. Now that is C over D, but you wanted D, right? So D is at the bottom. So let's bring it to the top by turning it upside down. And so you have to do the same thing to this. This is this over 1. So when you turn it upside down, you invert it, you get D over C is equal to this. And now you can find D. D is the numerator. Multiply on both sides by C. And you have D over 1 equals C into this, and that's the answer. So D is equal to C over A minus B all squared. So that's a problem in algebra. All right. So the next problem is the following. Oh, I'll come back to the same thing. All right. Let's just get this thing right. Oh, it's not copying. Why is it doing this? Maybe I need to have a big space. Ah. All right, so I needed to have a bigger space. So here it is, there's a story going on here. It has been observed that in a herd of gazelle, there is always at least one male for every 5 females. Right? If M is the number of males and F is the number of females, and the number of F of females is a multiple of 5, the rest of the question says, which is true? Which is true, and they give several options here. Good. You can see all that. It recognizes the greater than sign, which I'm grateful for. All right. So let's look at this question again. It's a wordy question. you got a herd of gazelle. So you got these animals, a whole herd of them. And it says that there's always one male for every 5 female, at least. Now that's an important point. There's at least one male. So you could have 2 males or 3 males or whatever. But there's at least one male for every 5 females. So every time you have 5 females, there is at least one male for that. See? Each time you have 5 females, you have at least one. See? Now this number of females is a multiple of 5. So you have, if you break them all up into groups of 5, then you can see that you have several groups, but there are M males. So the number of males will be at least M, because you have M of them. So in other words, the total number of, suppose you had N groups. We don't know how many groups there are. Okay. Then you will have at least M. So the total number of females is 5 times F. Oh, I'm sorry. The total number of females is F. I should not have used the symbol F for this. F is got a special meaning. It's the number of females altogether. So the total number of females altogether is F, and there are F over 5 groups here, right? F over 5 groups. And each group, right, you have is greater than 1. There is at least one male in each group. So you will have F over 5 is greater or equal to M. So this is the equation that comes out from this. Right?
Sir?
Yes.
Isn't there more males? Because there could potentially be 3 males for a group of 5 females, because it's only at least 1.
Oh yeah, you are right. I'm sorry. There's at least one. There's at least one male. I should have noticed that. So the number of males is okay. Let's take some examples. Suppose I had only 2 groups. I could have had 2 males here, and I could have had, say, 3 males here. Okay, in which case I've got 10 females, right, and I've got 5 males. Okay, so the 10 over 5 is the number of groups. That's 2. So that number is going to be less than 5. So you are right. So this is going to be less than M. Sorry about that. So when you try it with a small number, you will see how the inequality works. Okay, I'm sorry this is so messy, but it's so messy, but I'm sure Lionel would not mind. Okay, so I just want to clean this thing up. Okay, so in the end, you got that F is less than or equal to 5M, and one of them is that. There's it here. That's the one that we're looking at. Okay, so the next problem is the following. All these problems are very interesting. They've been taken from former Olympiads. And so over a long period of time, I think right from maybe 2011 or something like that. And that is how I created the book, The 1000 Problems. but a large number of them were from previous Olympiad problems, Olympiad papers. So these are good. This is a good revision because we are looking at problems which the kind of problem that you can expect in an Olympiad paper. So the next question here is the following. Oh, I'm doing this again. Oh God. I think my typewriter is a little bit sticky, so that is why it's not accepting this. Let me just get my thing in order here. I hope it did the same thing again. Oh God. Okay, let's go a little bit faster. See? Well, let's hope it works now. Ah. Thank you, God. Right, so this question here is calculate a product, well, actually it's not a product, it's a difference between two products. 1, 2, 3 squared, is this? Is 1, 2, 3 squared? Yeah, that is probably 1, 2, 3 squared.
No, sir, it's correct.
1, 2, 3, 2. No,
Yes.
actually it can't be, Ali. That I think, in other words, what was written there from which we are reading, that is wrong. If it's 1, 2, 3
Prof.
squared, we can't solve this problem.
Prof, in your book, it's squared.
It is, eh?
Yeah.
Oh, here's a first error, Ali. We'd better start preparing a list of errata straight away. Yeah. But I think if you go and look at the answer, you'll probably see the answer is fine. All right, so this is, it is squared here. You'll see just now why it has to be that, because there's a way of solving this problem as it is. So we are looking at 1, 2, 3 times 1, 2, 3 times 1, 2, 9 minus 1, 2, 4 times 1, 2, 5 times 1, 2, 6. Now, you can multiply the whole thing without a calculator. Right, multiply all these three numbers, multiply these three numbers, subtract it, and you can write down the answer provided you still have time to finish the paper, or provided you haven't died of old age. So whatever the case may be, you have to find some easier way of doing this. And the trick is to give a name X to one of these numbers. They're all clustered. They're all close to each other. 1, 2, 3, 123, 124, 125, and so on. So you'll see these numbers are coming from this lot here. They're all clustered together. All right, and that should give you a clue. So let X be one of these numbers, any one of the numbers, perhaps something closer to the middle, say like 1, 2, 6. And then we try to solve this problem by replacing these numbers in terms of X. So what you have here is X minus 3. Or maybe we should, because this is being squared, maybe we should let X be 1, 2, 3. That might be a better choice. Yeah. So now, so this is X and X. So you have X squared. 129 is X plus 6 minus this thing here will be X. 1, 2, 3 is X. So this is X plus 1 and X plus 2 because you've got 1, 2, 5 and x plus 3. Sorry, you got some gate crashes here. Get rid of them. Okay, and now this is very much easier to calculate. As you can see, this is x cubed plus 6x squared. And here you have to multiply these three things out. This trinomial, let's multiply that out first, and then expand that one, and with a minus sign in front. I'm not going to work it out, but you will have minus x cubed, you can see, x times x squared, and you also have minus 6x squared. See? Yeah. And you have some other numbers. So these immediately go away, you see, and you're left with just two numbers here. See? The something times x plus 6. I'm not going to do it. We will just imagine that it's minus 11x minus 6. I think that might be actually the answer, I'm not sure. And then you multiply. Now you can substitute. X is 123, so 123 times whatever the answer is, multiplied by 11, subtract 6, multiply by negative 11, subtract 6. And there you have it. You have the answer without using a calculator. It's one of those exceptional cases where you let x be a known number. Usually x is an unknown number. So here, the trick is to reverse what we normally do in solving equations, and we give a symbol to a known number, simplify it with x's in it, and then get to the answer. So it's a very nice problem, very nice problem. All right, that takes us to problem number 13. Maybe you guys, if you want to have a quick break, because it's 2 hours, but I'm not going to give you more than 5 minutes. But it'll mean early that the video will have to be silent for 5 minutes. And let that be, because I think the concentration span of most students is not more than 3 minutes. We've already gone on to 80 minutes. So it's now 10:21. Please be back at 10:25. Quickly go into the kitchen, grab a cup of coffee or whatever. Or if you don't think you need anything, you can just sit there, close your eyes, and meditate on what we have done. In the meantime, I'm going to have my
Professor? Sorry to bother you, Professor. Me and Ivan Moritz will have to be leaving the class now to go play a tennis tournament match, sir.
Sir.
Prof. Pillai, I think something went wrong. We can't see your screen anymore.
Oh, okay. Can you see it now, Ellie?
No.
Neither do
I can see the screen.
Okay, now it's coming up again.
Thank you, sir.
Okay, thanks for that.
Belinda, do you want to ask something, or I see your hand is up, or are you just testing the functionality?
Yes, I was just testing the functionality.
Okay, then you can lower your hand again, please.
Thank you.
I was trying to get into the chat column, Ellie, to see if there were any questions or any comments up to this point. But it would mean I have to get out of the screen, and I'm scared to do that because I've written some things on the whiteboard. Is there anything in the chat column which is worth addressing?
While the learners are trying to do the problems, and then they're posting the answer in the chat column.
Okay.
And then there's some questions about Google Classroom, etc., which I shall take care of.
Okay, good. All right.
So, but just for the learners to note, Prof. Pillai can't see the chat column. If you want to ask a question, rather raise your hand, and then I will alert him that there are a question.
Okay, thanks for that, Ellie. All right, we are now ready to start. We've taken a little bit more than 5 minutes. The next question is the following, is right at the top of the screen. what is 1/2 of 2 to the power of 20? Now, the gut reaction to most novices will be 2 to the power of 10, right? Just look for. Somebody might say 1 to the power of 20. Fortunately, none of you fall into that category. So we'll have to try to work this thing out. 1/2 of this is really 2 to the power of 20 divided by 2. And the second law of indices says that you have to subtract the indices to get 2 to the power of 19. So 1/2 of 2 to the power of 20 is 2 to the power of 19, not 2 to the power of 10. All right, so that's not a very difficult problem. I think it's a level 2 problem. Let me just go on. Okay, the next problem is quite a stinger. I think most people will die of shock when they see this kind of a problem. Let me just see. So reduce this fraction. This is a fraction here. I can't draw that line in between, which is called the vinculum. I can't draw that, but it's a fraction. So I hope that you understand that this is a fraction. So we're going to look at this fraction here and see. We're going to reduce it. In other words, take out the common factors and keep simplifying this thing. You can appreciate that this doesn't look easy at all. And this is where the power of mathematics comes in. It's a very beautiful problem to show how we can use the algebra that we learn in class to solve seemingly impossible problems like this. And also patterns. You know, when you do patterns, you normally use it in certain geometrical contexts, or even sometimes in algebraic context. But here you're going to use patterns very effectively. Let me draw this long line here. And the reason why I did that long line is I want to break this thing up. You see, you've got this 4851 occurring quite a few times here. And this likewise, you've got 8118 occurring quite a few times. So let us try to bring 4851 into this picture. Now, how do I do that? Well, I'll break this top number into a sum of several numbers. One has got 224 with lots of zeros. Then you got 4851 with lots of zeros. The next one you add 4851 again with lots of zeros. Here you got 4851 with only 4 zeros. And then at the end you got 4627. You're going to add several numbers. And I'm going to tell you what these numbers are. It's 224. But lots of zeros means 1, 2, 3, 4. There are 16 zeros. So it's 10 to the power of 16. Plus 4851. And here 4851, the number of zeros here would have been 12. So that's 10 to the power of 12. Oh, wait a minute. I can take out 4851 as a common factor because it will also be 4851 has got 10 to the 12 zeros here. This 4851 will have 8 zeros. So let me put down that is 4851 times a number with 8 zeros, you see. So you can take it out as a common factor. And this 4851 will have 4 zeros. And that closes it there. And then the last 4 digits, we can just keep it like that. And let's just increase this. And so we're trying to simplify the top one, and this, a similar kind of a thing will happen at the bottom. This time you have, okay. Mangope, can you please take your mic off? Mangope. So you got 8118. That's the number which occurs all the time here, so we can take it out. First, you got 1, 2, 4, 8, 12, 15. I think it's supposed to be 16 here, sorry. This has got the same number of digits as the top one. So it's 10 to the power of 16.
Prof, it's supposed to have 3 zeros at the end.
It's got to have
I don't think it has 4 zeros at the end.
It's got 3 zeros, huh? All right.
Prof, because there's only 3 numbers at the start of the top one.
Yeah. Okay. So it's got, thank you for that. All right, so you got 10 to the power of 16, and here you got 10 to the 12. The next group of this thing here will have 8 zeros. We are saying 14. One, two, three, 4. So that makes 19. You got 19 there as well. Yeah.
So I think it's 15. Not 16.
Yeah. So but at the top that is right. So okay, so we say this is 15 here. 15, 11, 7, and okay, and 3. Okay, right. Okay, so it's 8118 into that. So this last 81 has got 3 zeros in it, as you can see, but we still have that's where it stops. Okay, because this number will end on 8118 000, and this is 15 here. Right. Okay, so what we can do, the denominator, we can rewrite this. Let's just make the thing 8118 and take out the 3 zeros which are troubling us, and make this 10 to the power of 12 plus 10 to the power of 8 plus 10 to the power of 4 plus 1. I'm removing the 10 cubed from this and absorbing it into the 8118, right? So if you don't mind, just to save time, I'll replace it like that. And then I give a name to this object here, because I see this object here is occurring there as well, you see? At least parts of it. So let's give a name for it, like what we did before, and then we can simplify this. Let's call that thing X. So what happens here? You got 224 times 10 to the power of 16. And you got 4851. And this part here, I'm calling this thing X. So this will be X minus 1, you see? That plus that plus that will be X minus 1. So that object will be X minus 1. And here you have 4627. And the denominator is is 8118 1000 multiplied by x. Okay, now I seem to be running out of space here. So let's just move to the top of this screen and eliminate that original fraction to create space. Let's just take this thing out and move over to the top. I'm transferring this information all the way to there. Okay, so what do I have? I've got 224 times 10 to the 16. Now here I've got 4851 times x. Oh, yeah, it's 4851 times x. Now this, you got minus 4851 plus 4627. So you have 224. When you simplify that, you get plus 224. Actually, minus 224, because you got minus 4851, that's bigger, right? So you got that all over 8118 times x. Now when you look at this, you got 224 occurring twice here. See how it simplifies? This is quite a teaser. I'm going to take all this stuff out now because I've dispensed with it. In an ordinary classroom, I can go into the next board, but unfortunately, we don't have that facility. So let's see what's going on here. So at the top here, you got 224 into 10 to the 16 minus 1 plus 4857 x all over. But you must admit that you got 8118 and there's 1000 here. I missed that 3 zeros out. Right. Now remember what the x was. X was this thing here. 10 to the power of 12 plus 10 to the power of 8 plus 10 to the power of 4 plus 10 to the power of 1. That was x. Okay. Now, we use geometric, this is a geometric series. It's 1 plus 10 to the 4 plus 10 to the 8 plus 10 to the 12. So, when you got a geometric series, 1 plus r squared plus r cubed, here you got, this is your r squared, r cubed. This is r to the power of 4 minus 1 over r minus 1. This is a formula for a geometric series. Right? I'm not sure whether you have run geometric series in class, but you can, when you get the book, you can go and read the stuff, or otherwise you can check your own textbook to just get the formula for the sum of n terms of a geometric series. That is what we are using. And then you will see that this thing here is, your x is actually equal to x times 10 to the power of 4 minus 1. Yeah. This thing is equal to 10 to the 16 minus 1 all over 10 to the power of 4 minus 1. Which means that this expression here, this is the expression that we're looking at, see, is actually equal to x multiplied by 10 to the power of 4 minus 1. Sorry, unfortunately, this whiteboard is not the best place to be working in. So a lot of these things I have to eliminate, and it makes the communication a little bit difficult. But just to tell you what we have 2 to the power of 24 times this, and we just saw that this is x multiplied by 10 to the power of 4 minus 1, and then that 24 got absorbed into that, and at the bottom you've got what we had there, but there's an x here as well, and these x's will cancel off, and eventually you have 224 times 10 to the power of 4 minus 1. I think I missed out here somewhere, but whatever it is. I've broken the back of this problem. So I don't know where the error is, but somewhere along the line, there would have been some other term. Oh, this 4857x. I think that still sort of remains. So I would have had 4857. I think I have something like this. All right. Sorry, but you get a smaller fraction now. You get this kind of a thing, and then you'll have to look at this thing again and simplify. You can still simplify further. Right? I don't have the right numbers here. Somewhere along the line there was some calculation error, but you will see this part here. If you use your rules for divisibility, 9. This is 9 times 902. This thing here. See, and then you also see that 11 goes into this, because the alternate sum method tells you that 8 plus 1 is 9, 1 plus 8 is 9. So this bottom part can be factorized quite nicely into 11 times 82. And when you do that, you will see quite a lot of these terms. Even this 82, the 41 goes into the numerator. And in the end, you have a very nice answer with a 3-digit number over a 4-digit number. So that original 16-digit number, or whatever it was, 19-digit number or 19-digit number, it simplifies to a nice fraction. And that is what I call taming the monster. So you can use mathematics to do all kinds of beautiful things, but please do this. Do this on your own now. Try to do it on your own. Just remember that somewhere along the line you have to make a substitution for x and simplify it and come right down to the answer. And when you do that, you'll get a great sense of joy that you have been like a lion tamer, a lion defeater, destroyed a monster. All right, so let's get on to the next problem, which is the 15th problem in our lot. That took a long time. So let's get rid of all this, lots of drawings. And okay, so the next problem is not going to be as frightening as the previous one. Okay, let's write all this thing neatly. So the question is the following. On a line segment with points R, A, T, and E, so you have a line segment somewhere, right? And you got points R, A, T, and E. I presume it's in that order, well, hopefully. So you got R, A, T, E are points on the line segment. I'm not very good at doing all kinds of pretty things, but at least let me put a little bit of red into this to show that I also have a touch of elegance. Most people, when they make these presentations, they make beautiful presentations. I cannot cope with that. So on the line segment, the ratio of RA to AT is 1:3. Now this is an important problem because it involves ratios. I'm going to tell you how you handle ratios. There's one way of handling ratios which is very, very powerful and very effective. See, ratios, when you say it's 1:3, it does not mean that one of the numbers is 1 and the other number is 3. It doesn't mean that. What it means is that if one of them is x, then the other is 3x. See? That's what it means. In the same way, RA to AT. Oh, okay, that's RA to AT. AT to TE. AT is here to TE is 5:2. Now this time it's 5:2, but what you do is make it 5y and 2y, right? It's 5 times some number, we don't know what it is, but we can call it y, but that will be the actual value of this thing. Okay, so what does this mean now? Then the problem is to work out RA over TE. Now, actually, you want RA over TE. You know this over this, and you know this over this, and you want to work out that over that. Well, it seems to me that you can RA over TE. Why don't we divide and multiply by the same thing? RA over AT, divide by AT, and multiply by AT so that the fraction remain the same, and leave that denominator intact. Now if you do that, then RA over AT, we already know what it is. It's 1/3. And AT over TE is 5/2. So this is 5/6. So this is a very easy way of doing it, but you have to divide and multiply by AT so that you could use the information that is given. RA over AT is 1/3, and AT over TE is 5/2. Okay. Otherwise, you can use this method that we were embarking on at the beginning. And from here, the problem is to find x over 2y. That is what you need to do, x over 2y, RA over t. Right? And you don't know what this is. That's a problem, you need to find it. But you do know that 3x is equal to 5y. Because both of them are equal to AT. Right? So you see, algebra, you have to think now and try to manipulate the given information so that you can get to your answer. So the first question is, what is the goal? What are we trying to find? We're trying to find RA over TE. In symbols, what does it mean? It means it's x over 2y. So this is what I need to calculate. This is the RA over TE that I need to calculate. Now, can I calculate this? Well, I have some equation involving x and y. So why don't we do that? So 3x is equal to 5y. So x itself is 5y over 2. So we can make x to be 5y over 3 at least. X is 5y over 3. And you're dividing that by 2y. So you might as well put 2y at the bottom. The y's cancel. And you come back to 5/6. You could have done it that way. Right? Either way. But I like this method here because for ratios, you can tackle lots of problems involving ratios. If you know the ratio, you don't say that one is equal to 1 and the other is equal to 3. You say one is x and the other is 3x, and try to get equations and solve the problem. Mathematics is all about getting to equations to simplify. The problems are often to find something, some unknown, you don't know what it is. So that's where mathematics steps in and says, I don't know what the unknown is, I'll call it X. And that's the jump from ordinary arithmetic to mathematics. You call an X, you call something an X, and then you create an equation involving X or Y or whatever, or equations, and then you use your school mathematics, which tells you how to solve equations to solve those equations. Once you bring it to that, to get the equations, use your context to get the equations, then you can solve your problems. Then you write it in mathematical terms. Whatever the problem is, you write in mathematical terms because you are using equations. And once you do that, then you can use your techniques of solving, finding solutions to equations to get to the answers. So that is a strategy in many cases. If you want your unknown, just call it X and go ahead. Try to get equations. Even this next problem here is, but the other thing is, sometimes you can use your common sense, like in Olympiad problems, often you have to use common sense to simplify the problems. You can get to the answer much more quickly without the equations. The equations will always get you to the answer, but you can use logic to get to the answers. Now look for instance this. A petrol tank weighs 34 kgs when empty and 54 kgs when full, kilograms. So the question is now, calculate its weight when it's 2/3 full. Now, this is not a very difficult problem. So I'm just going to put down, might as well use. So you got a tank, a petrol tank. Let's put a little lid on the top there. And when it's full, it weighs 34 kgs. Petrol tank weighs 34 kgs. Oh, when empty, and 54. When it's full, it's 58. Okay, I should have put 58 here when it's full. But when it's empty, it's 34. So where does the weight come from? It's the weight of the tank. So the petrol itself, when it's full, the weight of the tank plus the weight of the petrol is 58. So the petrol itself will have to be 58 minus 34. If you remove the weight of the tank, you get 24. So this is a full tank, or the weight of the petrol is 24. 24 when it's full, but you want it to be 2/3 full. So the amount of petrol is just 2/3 of 24, because you are interested in this weight here. This petrol here is 2/3 of that weight, which is 24. So that is 16. So this petrol there, when it's 2/3 full, is 16, but the tank itself is 34. And the question is, calculate its weight. So in other words, you want the weight of the tank together with the petrol. So the actual weight will be 34, the weight of the empty tank plus the weight of the 2/3 of the petrol. Okay. All right. So that is how you do this. So I didn't use X's. I could have used X's and Y's, and I could have got equations. I could have said, let the weight of the petrol tank be X, petrol tank, and the full petrol when full, be Y, and then get equations. And you can solve. All right, I'll leave that to you. But without equations, you can still solve the problem. Okay, so let's get on to the next problem. Makasha, can you please put your speaker off? Everyone, please note that you need to take your speakers off and just check that out, because everybody can hear what's going on in the room otherwise. Makasha, you haven't taken your...
Prof. Pillai, Lendiwe has a question.
Yes, okay.
Lendiwe, you can go ahead. Lendiwe, do you have a question or you're just testing the functionality?
It was a mistake, sorry.
Okay, it's fine. Just lower your hand again.
Are there any more questions?
You can continue, Prof.
All right, so the next question involves percentages. It says that successive discounts of 12% and 25% is the same as a single discount of X. Determine X. So what does this mean? It means that there is some item which is being purchased, bought, and two discounts are given. They are successive. In other words, first you get a discount, and on that discounted amount, you get a second discount. And in the end, it's like two discounts is equivalent to a single discount. What is X? See, most people will say 12 plus 25 is 37, and they will say that is the answer. But it's not as straightforward as that. There is something a little bit more sinister about this problem. Okay, so why not try to see, let's take a particular price of that item. That's one of the ways of doing it. We'll say, suppose the price of the item is, say, 1,000 rands or whatever. Take a nice number so you can work out percentages. So let price of item let's make it 100, so that 100 rand, so you can work out the percentages nicely. Okay, so what does this mean? The first discount, after the first discount, %12 of 100 is 12 rands, right? That means you take away 12 rands, so you would have paid 88 rands. You got a 12% discount. But then you got a second discount of 25%. Now 25% you all know is a quarter. So in other words, a quarter of this amount on that 88 was taken out. That gives you the second discount. So the final price is 66 rands. So in other words, the original price of 100 rands came down to 66 rands. So the discount now is easy to calculate. Discount is a percentage, right? As you see what the reduction is from 100 to 66. You subtract the two, you get 34. But that is 34 over 100. We chose a nice number, 100. So 34, the actual percentage discount will be 34 over 100 times 100 over 1. That will be 34%, converting that into percentages. So the single discount is 34%, not, as some people might have suspected, 37%, 12 plus 25. Okay? You could have done it in a more complicated fashion using X's. Instead of saying let the price be 100, you could have said, let the price be X rands. Right? In which case, you can still make the calculation, but now you don't have any numbers to work with. In that case, what you would have had is the first discount will be 88% of X. So it's 88 over 100 times X, right? Not times 100. So it's 88X over 100. And then the second discount, after the second, there's 25% is taken away. So you got 75%, you're paying 75% of the actual amount, which is 3/4. So it's 3/4 of this amount. And that is the final amount that you will pay. And you will see here that 4 goes into 88 22 times. 22 times 3 is 66. So it's 66x over 100. So you can see you are paying 66% of what you actually bought it, or what the original price was. So if that is the actual purchase price, so the discount will be 34%. You could have done it using extras as well, but choosing the X to be 100, because this evidently the price of this is quite independent of, the discount is independent of what the actual price is. They don't tell you the price, so therefore it doesn't really matter what the price is. So therefore you can choose your own price. You see, that is the trick. And the nice price to choose will be 100, because you can work out percentages very easily from that. Okay. So the next one, all these are all, as I said, they're all past Olympiad problems. There is an Olympiad committee which spends a weekend thinking up problems. These are all original problems, only unique to the South African Maths Foundation. And these problems were designed at some weekend. So they all get together and they work out the problems set. So this next problem here, which I'm about to share with you, oh, it's a very wordy problem. Oh, God. All right. We'll leave it like that because we can write in the other place. So let's have a look at this problem. What does it say? In Kitty's town, 10% of the dogs think they are cats. Oh, that's really not a nice thing to say about dogs. Those dogs would feel very insulted if we tell them that we are suspecting that they are cats. So be that as it may. So 10% of the dogs think that they are cats. And 10% of the cats think they are dogs. All right, so you've got a mad world out there. All the other cats know that they are cats, and all the other dogs know that they are dogs. Hopefully, there are some sane animals amongst them. In total, 20% of the animals consider themselves to be cats. So what percentage of the animals are actually cats? What percentage of the animals are actually cats? All right, let's see now, how does one go around doing this? Let's read and understand the question. In Kitty's town, you've got dogs and cats. So you got, let's just draw a little diagram here maybe. Kind of understand this thing. And you got dogs on the one hand. And you got cats. Now 10% of dogs think they are cats. So these dogs here, these are the mad dogs. 10% of this lot here, right? Think they are cats. So these think they're cats. Now these other guys think that they are dogs. They're okay. As far as the cats are concerned, the 10% of these guys think they are dogs, right? And the other ones think that they're cats. Okay, so in total, 20% of the animals consider themselves to be cats. So, in other words, that darkened spot, they think they are cats, and this undarkened spots here think they are cats. So when you join these two, then that constitutes 20% of the total animals, of all the animals. 20% of all the animals, dogs and cats, they consider themselves to be cats. Okay, so maybe we can do it like this. We can say, suppose there are X dogs and Y cats, right? So what does this mean? It means that the number of animals which think they have themselves as cats amongst the dog population is just 10% of them. So 10%, which is 1/10 of the dogs, these guys here, they think they are cats. Now from the other population, 10% of them think that they are dogs. So the remaining ones think they are cats. But we want to know how many think they are cats. So 90% of them, which is 9/10 of Y now, think they are cats. All right. And this makes up 20% of the full population. So this is 1/5, 20%. The full population is X plus Y. So that is how you get your equation. You get an equation involving X and Y. Only one equation involving X and Y, where X is the number of dogs and Y is the number of cats. So let me just go over this again. We give a symbol to the number of dogs and a symbol to the number of cats, and then we try to calculate how many of them think they are cats. Like amongst the dogs, only 1/10 of them think they are cats, and amongst the cats, 9/10 of them think that they are cats. So altogether, the total number of animals that think they are cats is this, and that's where we are. Okay, I see I've exceeded my time. I didn't even realize it. So now you have to multiply.
Prof. Pillai, some of the learners are asking about the time.
Yeah.
I think we still need to have 3 problems to cover. Do you want to continue, or do you want them to work out the problems?
Yeah. I think what I will do is,
their own time?
Yeah, it's not fair because we said we're going to finish at 11. I'm sorry, I forgot that. I didn't realize that we had gone beyond the time. Let me just finish this and then we can close up. All right, so here you have this, and the question is now, what percentage of the animals think that they are actually cats? So you need to know what percentage of the animals are actually cats. So the cats amongst them are Y, and if you want to work out the percentage, the fraction of the cats amongst that cat and dog population is the Y cats, and altogether you have X plus Y. So this is the fraction, and you need to work out this multiplied by 100 to get the percentage. So we need to calculate that. Now, you've got one equation involving X and Y, so we can simplify this, get rid of the fraction, multiply by 10. On both sides, you get X plus 9Y. If you multiply this by 10, you get 2X plus 2Y. And this allows you to get the X's in terms of Y's, because you can put 2X minus X if you bring it to that side, and you get 9Y minus 2Y is 7Y. So X is actually 7Y. So it means that this part here is 7Y, which makes it very nice, because this is now 7Y plus Y, and you get as a percentage. 100. Yeah. So you get 100y over 8y, and the y's cancel, and 100 over 8 is 12.5%. So the answer to this question is 12.5%.